Student, in the chapter motion in plane, we already discussed up to the dot product or scalar product of vectors, and also we know about the application of dot product or scalar product of the vectors. Today we start with the another type of vector product known as vector product or cross product. Okay, so first we have to know about the definition of cross product, for which see this diagram carefully. Here A and B are two vectors acting from the point O by making an angle theta. So then the cross product of these two vectors A and B is defined as A vector cross B vector equal AB sin theta n cap. AB sin theta n cap, where AB sin theta represent the magnitude of the cross product and n cap represent the direction of cross product. Therefore, whenever we perform the cross product of two vectors, we get magnitude as well as direction. Means we get a vector quantity. That's why the cross product, another name is vector product. Okay. Now we have to know the direction n cap. The direction n cap. Okay. So remember, n cap is a unit vector perpendicular to the plane where the both vectors A and B are situated. Okay, and remember one thing, this perpendicular may be in two direction. Okay, so the n cap may be perpendicular to this whiteboard and directed outward, and may be perpendicular to this whiteboard and directed inward. In which direction the n cap is there, to know about this we have to know the two different rules. Number one, right hand screw rule, and number two, right hand thumb rule. By these two different rules we can determine the direction of cross product. So first one, right handed screw rule. Okay, so we have to take a right handed screw and we have to place the right handed screw at the point O, which is the intersection of the two vectors A and B. Now if you want to determine A cross B, okay, so then you have to rotate the right handed screw A to B, means in anti-clockwise manner. Whenever you rotate in anti-clockwise manner, then the screw move in the outward direction. So then the direction of the cross product is perpendicular to this whiteboard and directed outward. But if you want to determine B cross A, then you have to rotate the right handed screw from B to A, means in clockwise direction. Then the screw move into the whiteboard, means then the n cap is perpendicular to this whiteboard and directed inward. Okay. Secondly, about the right hand thumb rule, you have to know to determine the direction of cross product. Okay. So now you have to keep your right hand like that. Okay, where your curled finger represent the direction of rotation. That is, if you want to determine A cross B, so then you have to give the rotation of your curled finger from A to B. Then your thumb will give the direction of cross product. If you want to determine B cross A, then you have to keep your right hand like that. Okay, where your curled finger gives the rotation of the vector from B to A and your thumb will give the direction of cross product, that is the direction n cap. Okay, so by these two different rules we can determine the direction of cross product of the two vectors. Now we have to know some properties of the cross product. Number one, cross product or vector product is not commutative. But in case of dot product, we see there the dot product is commutative. But remember, cross product or vector product is not commutative. Means A vector cross B vector not equal B vector cross A vector. But cross product is anti-commutative. What do you mean by that? A vector cross B vector equal minus of B vector cross A vector. Means the magnitude of A cross B and B cross A are same, but their directions are opposite. Means the cross product of two vectors are anti-commutative. Secondly, vector product is distributed over addition. See the expression A vector cross B plus C. So here A cross distributed with B vector as well as with C vector. That's why we write here A vector cross B vector plus A vector cross C vector. Means vector product is distributed over the addition. Okay. Next, the cross product of two same vector, that is A vector cross A vector. What is the angle between them? 0 degree. Then from the definition, mod A vector sine 0 degree n cap. Sine 0 0, that's why it is 0. So therefore cross product of two same vector always gives 0. Next, if the cross product of two vector is 0, then we can say the two vectors are parallel. This is very important for the numerical purpose. Whenever the cross product of two vector is 0, then we can say that two vectors are parallel to each other. Here is the proof of this statement. See the proof. A vector cross B vector equal AB sin theta n cap, and that is 0. So therefore sin theta equal 0 by AB n cap means 0. So for what angle of sine gives 0? That is sin 0. So sin theta equals sin 0. So theta equals 0 degree. So means the angle between the two vectors 0 degree means the two vectors are parallel to each other. Okay. Next we have to know about the cross product of orthogonal unit vector. What do you mean by the orthogonal unit vector? That is I cap, j cap and k cap are the orthogonal unit vector. Okay. Now see, I vector cross I vector. According to the definition, mod I cap, the angle between them 0 degree means sin 0 degree n cap. Sin 0 0 means it is 0. Similarly, j cross j is 0, k cross k is also 0. Means whenever we perform the cross product of same orthogonal unit vector, then it gives 0. Now we have to know the cross product among different orthogonal unit vectors. Okay, that is I vector cross j vector. So according to the definition, mod I cap, mod j cap, angle between I cap and j cap is 90 degree. So therefore sin 90 degree n cap. This is 1, this is 1, this is 1, means it only n cap. And according to the definition of cross product, we know the direction n cap. Okay, so n cap is a unit vector which is perpendicular to the plane where I cap and j cap is situated. I cap situated along x axis, j cap situated along y axis. So therefore n cap is along z axis, and along the z axis unit vector is k cap. That's why whenever we take I cap cross j cap, it will give k cap. To remember this situation, you have to remember this diagram. Just see I cap, j cap, k cap, and we rotate in the clockwise manner. So therefore whenever you perform the cross product I cross j, it will give k cap, it will give k cap. Next j cross a, j cross k, it will give I cap. Next k cross I, it will give j cap. So whenever you rotate clockwise, we get k cap, I cap and j cap. But if you rotate in anti-clockwise manner, then this k cap replaced by minus k cap, I cap is replaced by minus I cap, j cap is replaced by minus j cap. Okay. Next, we have to know how we can determine the cross product of two vectors. Suppose there are two vectors. A vector equal axi cap plus ay j cap plus Az k cap. B vector equal Bx I cap plus By j cap plus Bz k cap. To determine A cross B, okay, we have to take a determinant form, and within that determinant we have to write I cap, j cap, k cap. Below I cap, j cap and k cap, we have to write the component of I cap, j cap, k cap of the two vectors A and B like this. Okay, as A cross B, first we write the component of A vector, next we write the component of B vector like this, that is Ax, Ay, Az, Bx, By, Bz. We know that whenever we perform the cross product, we get a vector quantity. That's why the result of this cross product we get in terms of I cap, j cap and k cap. So how can you determine the coefficient of I cap, j cap and k cap? Whenever you determine I cap, then you close the I cap and start the cross multiplication from the next one. So next one is Ay. So therefore Ay Bz minus Az By, and this is the coefficient of I cap, plus j cap. Whenever you determine j cap, close the j cap and start the cross multiplication from the next one, that is Az Bx minus Ax Bz, and this one, this is the component of j cap, plus k cap, and whenever determine k cap, close it and start from the next one, that is Ax By minus Ay Bx, which is the component of k cap. So by this particular process we can determine the cross product of two given vector. Okay, and lastly we can determine a unit vector which is perpendicular to the plane where the two given vector is situated. Suppose there are two vectors, A vector and B vector, situated on a particular plane. Okay, you want to determine a unit vector which is perpendicular to that plane. So the formula for that, n cap is a unit vector which is perpendicular to the plane where A vector and B vector is situated, is given by n cap equal A vector cross B vector by mod of A vector cross B vector. So this is the formula to determination of a unit vector which is perpendicular to the plane where the two vectors A and B are situated. Okay, so next we know about some application of the cross product. Okay, so now the application of cross product. Number one, by the cross product we can determine the area of a parallelogram as well as the area of a triangle. How? If the two vectors, suppose A and B, representing the two sides of a parallelogram, then the area of the parallelogram is given by mod of A cross B. Similarly, if the two sides of a triangle represented by two vectors A vector and B vector, then the area of triangle is given by half of mod A vector cross B vector. Okay, next we can determine the torque also. The torque tau equal R cross F, where R vector is the position vector and F vector is the force vector. We can determine the angular momentum also. Angular momentum L vector equal R vector cross P vector, where R vector is the position vector and P vector is the linear momentum vector. Okay, so these are the some application of cross product you have to know. Now there is a sample problem of cross product. See the problem carefully. If A and B denote the side of a parallelogram and its area is AB by 2, find the angle between A and B. So there is a parallelogram whose two sides represented by two vector A and B, and the area of parallelogram is AB by 2. Then you have to determine the angle between A vector and B vector. So how it is possible? See the solution. We know that the area of parallelogram mod of A cross B. Mod of A cross B means only the magnitude of A cross B means only AB sin theta. and that is given AB by 2. So that's why it is equal to AB by 2. So AB cancel and sin theta equal half. For what angle of sin value? It is half, that is sin 30 degree. So sin theta equals sin 30 degree. So therefore theta equal 30 degree. Okay. So student, this is all about your the vector analysis chapter. Okay. Now you have to solve lots of numerical on this particular chapter. I provide you some solved and some are unsolved numerical, and after few days I will take a test on this particular chapter. Thank you.